The Angular application setup process may have seemed a bit like wizardry. Packages and libraries magically installed, and the TypeScript compiler psychically knowing what to do. Welcome back to Angular 2 Getting Started from Pluralsight. My name is Deborah Kurata, and in this module, we revisit the basic files we need to set up an Angular application. What looked like installation wizardry was instead a set of carefully defined setup files. Let's peek behind the curtain and see what those files are, what information they contain, and how to use them. In this module, we'll take a closer look at the TypeScript configuration file, the TypeScript definitions file, the npm package file, the system.js configuration file, and the scripts defined in index.html. Then we'll revisit the bootstrapping process and take a brief look at the Angular CLI. Let's get started. To begin coding with Angular quickly, at the beginning of this course, I provided the basic files needed to set up our development environment. Those files are part of the starter files you may have downloaded from the GitHub repository for this course, as detailed in the First Things First module. Now let's revisit each of these files and see what they do. Note that the content of these files may change over time, so don't worry if your files don't look exactly as those shown in these demos. With that said, let's get to know some of these files better, starting with tsconfig.json. This file is a TypeScript configuration file. It specifies TypeScript compile options and other settings. The TypeScript compiler, TSC, reads this file and uses these options and settings. The presence of this file in a folder indicates that the folder is the root of a TypeScript project. Most of today's browsers only understand the ES5 version of JavaScript, so we need to tell the TypeScript compiler to transpile our TypeScript code into ES5 code, so ES5 is our target. The source map option defines whether TypeScript should generate map files. Map files assist with debugging, so it's a good idea to set this to true. The emit decorator metadata and experimental decorators options provide support for our decorators. These must be set to true or our Angular application won't compile. The no implicit any option defines whether the TypeScript compiler will default untyped variables to a type of any if it can't infer the type. If we want to ensure all of our variables are strongly typed, we can change this to true. Feel free to add or change this file as needed to configure the TypeScript compiler to the needs of your application and environment. So, disappointingly, the TypeScript compiler isn't psychic. It uses this file to know how to compile our TypeScript code. Some JavaScript libraries extend the JavaScript environment with features and syntax that the TypeScript compiler doesn't understand. We can use TypeScript definition files, d.ts files, to tell the TypeScript compiler about the libraries we load. These days, many libraries include their type definition files within their npm packages, so they are retrieved when the library is installed. We don't have to do anything extra in this case. For example, here is the TypeScript definition file for the common package we imported in the last course module. This file was downloaded when we used npm install to download the Angular packages. For those libraries that don't provide their type definition files as part of their npm packages, we can use a typings tool to find and retrieve these files. The typings.json file contains the list of these libraries. We specify the typings for core.js, which brings ES 2015 capabilities to ES5 browsers. And we need Node to develop and build our application, and to use tools such as LightServer, even if we won't use Node as our backend server. This typings.json file is processed automatically as part of the installation process, as we'll see when we look at the package.json file. Let's look at that next. One of the most important files for successful setup and development time execution is the npm package file, or package.json. When setting up Angular, we use npm to install the Angular libraries and all of their dependencies. And we use npm to run scripts, such as npm start to launch our application. Looking at the contents of this file provides helpful insight into how npm knows what to do. This file contains basic information about the application, such as the application name, version, author, description, and so on. For our purposes, the key settings in this file are scripts, dependencies, and dev dependencies. These are the settings that provide the magic when installing and running an Angular application. Let's look at the dependencies first. In this file, there are two sets of dependencies. The dependencies define the libraries that our application needs to run. Here is Angular, System.js, our module loader, and reactive extensions, for example. And I added Twitter Bootstrap here because we use it in the sample application for styling. The dev dependencies define the additional libraries we need for development. Here is where we define TypeScript and some support libraries that the scripts use. We'll talk about these scripts in a moment. At the beginning of this course, we set up Angular by typing npm install from the folder containing this file. When we issue that command, npm reads these dependencies, locates each of these libraries in its repository by name, and installs the specified version. But please note, as with any software, these libraries will most likely change over time, and the versions you see may differ from the version numbers shown here. Feel free to add or modify these entries as needed to include any other third-party library or npm package. Up here, we see the list of scripts that we can run with npm. We can execute any of these scripts from the command line using npm run and the script name, except for start, which does not require the run keyword. Using npm run tsc runs the TypeScript compiler. We can use the -w flag with the TypeScript compiler to run the compiler in watch mode. This keeps the compiler running, awaiting changes to any TypeScript files, and recompiling as needed. LightServer is a lightweight static file server that we use to run our application without any backend server, and was specifically written for Angular 2. Using npm start runs the TypeScript compiler and the LightServer at the same time. So whenever we save a change to any of our files, TSC will recompile them, and LightServer will refresh the browser automatically so we can immediately see our changes. We saw this in action throughout the demos in this course. Using npm run typings runs the typings tool. For TypeScript to be strongly typed, it needs to know about each library's types. These files are stored in TypeScript type definition files, indicated with a d.ts extension. Most libraries install their own associated TypeScript type definition files, so we don't have to do anything extra to install them. We put any other typings files in the typings.json file. Running the typings tool installs any typings defined in this file. Post-install is called by npm automatically after it successfully completes the installation of the package. Here we have set up post-install so that after npm install is complete, any TypeScript type definition files in the typings.json file are installed as well. As its name implies, the System.js configuration file configures System.js. System.js is an ES module loader that automatically loads each of the files for our application. That way, we don't have to add script tags for every file we use in our application. The paths property defines an alias where our system files are located, in this case, in the Node Modules folder. The map property defines to the module loader where all of our Angular pieces are located. We looked at the packages property earlier in this course when we walked through the application bootstrap process. The app property defines which file in the app folder should be loaded first, which is main. and provides a default extension for the paths we specify in our import statements. Now let's move on to the index.html file. We've covered the contents of the index.html file previously in this course, but let's spend a moment looking closer at the libraries we are loading with the script tags. This first one is for Core.js. This library brings ES 2015 capabilities to ES5 browsers. We included the typings for this library in the typings.json file. A zone is an execution context that persists across asynchronous tasks. Angular uses zones for change detection and data binding, so we probably want that. Reflect metadata is used by Angular to support reading decorator metadata, so we probably want that too. And this is System.js, the module loader we discussed in the prior clip. So there is no wizardry here, just a set of carefully defined setup files. Next, let's revisit the bootstrapping process. Recall from the beginning of this course that we bootstrapped our root application module in the main.ts file as shown here. We use dynamic bootstrapping and the just-in-time or JIT compiler. This means that the Angular compiler compiles the application in the browser and then launches the application starting with the root application module, app module. This is similar to how most client-side web applications work. Alternatively, we could use static bootstrapping and the Angular ahead of time or AOT compiler. By compiling ahead of time, we can produce a much smaller application that launches faster, especially on mobile devices and high latency networks. To use this static option, the Angular compile runs ahead of time as part of your build process and produces a collection of files that contain class factories. Setting up a build process and using the AOT compiler is out of the scope of this course, but I did want to make you aware of it and show you how this file changes when you use ahead of time compilation. The code to bootstrap a precompiled application is similar to what we have here. Note that I have not run the AOT compiler, so I don't have this factory. That's why we see a syntax error here. Notice how similar these two sets of code are. We use Platform Browser instead of Platform Browser Dynamic. We use Bootstrap Module Factory instead of Bootstrap Module. And we bootstrap the app module factory instead of the app module itself. Even though I've pasted both sets of code here so we could compare them, you would always use one or the other, never both. So I'll delete this code. For more information on the ahead of time compiler or AOT, see the Angular documentation. Next up, let's take a quick peek at the Angular CLI. Throughout this course, we have built our Angular application manually. That is one of the best ways to learn, by building each component and typing each class definition and metadata. But as you start to build your application, you may want to use the Angular CLI, or command line interface. The Angular CLI can generate the pieces of our application for us. With simple command line syntax, we can create a working Angular application with all of the required starter files. And we can add components, directives, pipes, services, or Angular modules to that application. This command adds a new component to the application called product list. The CLI provides much more, including generating unit and end-to-end tests. The best place to start with the CLI is the cli.angular.io website. There we can get started with the CLI and learn about its commands. Here is the Angular CLI website. If we click Get Started, it takes us to the GitHub repository. At the time of this recording, the CLI version is Beta 16 and still changing, so we won't demo the CLI here. Looking at the README, and navigating down to the installation process. We see that we can install the Angular CLI with a simple npm command. To generate an Angular project, type ng for Angular, new, and the project name, such as APM. The CLI creates a set of files for us. These files include all of the setup starter files, the root application module, app module, and the root application component, app component, along with the first cut of unit and end-to-end tests. We just need to fill in the details. We can also use the CLI to generate components, directives, pipes, and services, as detailed here. The Angular CLI provides a quick and easy way to build your Angular application without the need to download or install setup or configuration files. And I'm sure it will only get better and more fully featured as time goes on. In this module, we revisited the setup files. We found that the TypeScript compiler is not psychic. Rather, it uses the TypeScript configuration file for options and settings when compiling our TypeScript code. We peeked at the TypeScript definitions file containing the typings we need. We then saw that npm is not wizardry. Rather, it uses the npm package file to specify the operation of npm install, npm start, and npm run. We looked at the System.js configuration file and how it configures the module loader that we use. And we looked at the libraries specified in the index.html file script tags. Then we revisited the bootstrapping process and talked about the bootstrapping differences when using JIT versus AOT compilation. Lastly, we took a quick look at the Angular CLI. Consider trying it out to generate the boilerplate for your application. Only one module left. As you have seen throughout this course, Angular provides a consistent set of patterns for building components, templates, and services, helping us to come up to speed quickly. Welcome back to Angular 2 Getting Started from Pluralsight. My name is Deborah Kurata, and the final words in this course include a recap of our journey, a few pointers to additional information, and a look at a broader description of Angular. Let's jump right into this short module. The goal of this course was to guide you down the right path, making your own adventures with Angular 2 more pleasant and productive. Let's recap our journey and review the answers to the key questions we identified at the beginning of this course. What is a component? We discovered that a component is a view, defined with a template, logic, defined with a class, and metadata, defined with a decorator. Where do we put the HTML for our user interface? Either in the metadata using the template property or in a separate HTML file using the template URL property in the metadata. When should we use binding? Anytime we want to display a component class property value in the view. When we want to control the DOM by setting a DOM element property in code. When we want to respond to user actions. And when we want to display a component class property and update the property when the user makes a change. Why do we need a service? We uncovered several reasons for building a service: to implement functionality that is independent from any particular component, to share data and logic across components, and to encapsulate external interactions, such as with data access. And how? How do we build an Angular application? With code that looks like this. Export a class, attach a decorator, and import what we need. Then put each component directive and pipe in its appropriate Angular module. Along the way, each module provided a set of checklists containing steps and tips. Feel free to revisit and reference these checklists as you start building your own Angular applications. This course covered the basics, But there is so much more. On Pluralsight, the Angular 2 First Look course provides a comparison of Angular 1 to Angular 2 and presents a more full-featured sample application. And watch for additional Angular 2 courses coming soon to a device near you. The Angular 2 documentation is very comprehensive and growing every day. It is a great reference to everything Angular. And I've set up a GitHub repository for this course so you can use it as a starting point or learning aid. It provides starter files if you want to try building an application yourself, or you can review the completed course files here. At the beginning of this course, we defined Angular as a JavaScript framework for building client-side applications using HTML, CSS, and a language such as JavaScript. But this is a somewhat narrow view of Angular, focusing on using it just for client-side web applications. But Angular is actually so much more. A better definition is that Angular is a platform. It supports multiple languages, multiple templating syntaxes, and multiple rendering targets. It has features to support mobile web, such as Material Design, a set of widgets that work across devices, Angular Universal to pre-render views on the server, and Web Workers for background processing. And Angular supports native mobile development using products such as Ionic and NativeScript. Keep an eye on Pluralsight and Angular I/O for more information on these exciting technologies. Congratulations, you've made it. You've completed the journey through the basics of Angular 2. But the road goes ever on and on. There are many more paths for us to take and so much more to learn. Thoughts or comments about this course? Please use the discussion tab on the Pluralsight page for the course to leave your feedback. And follow me on Twitter. It would be great to hear about your Angular 2 adventures. Thanks for listening, and I hope you enjoyed this journey through Angular 2.